Now we are discussing about the specific speed. Specific speed nothing but the speed of the turbine. We compare the speed of the turbine, which is identical shape, geometrical dimensions, blade angles and gate opening, etc. Nothing but prototype and actual model we are comparing with the actual turbine. So we are comparing the prototype, but of size that will develop unit power when working under the unit head. It is denoted by symbol N. The specific speed used in comparing different types of turbines, as every type of turbine have different specific speeds. Every turbine కూడా మనం చెక్ చేస్తాం, ఎందుకంటే different specific speeds ఉంటాయి కాబట్టి. In MKS units, unit power is taken as 1 horsepower and unit head is taken as 1 meter. In case of SI units, unit power is taken as 1 kilowatt and unit head is taken as 1 meter. Whereas overall efficiency, we already know that soft power by runner power. Soft power, power developed by runner power, rho z QH by 1000. Nothing but power developed capital P. H is under the which turbine is working. Q is discharged to the turbine. Power developed or soft power. Power developed or soft power P nothing but efficiency naught into rho z QH by 1000. This term is comes to left side, whereas we can see that P is efficiency naught. P is equal to efficiency naught into rho z QH by 1000, whereas P is directly proportional to Q and H. P is directly proportional to Q, discharge and head, whereas D is diameter of the actual turbine. D is the diameter of the actual turbine. N is speed of the actual turbine. U is tangential velocity of the turbine. Ns is specific speed of the turbine, and V is absolute velocity of water. The absolute velocity and tangential velocity head on the turbine is related as U is directly proportional to V. You can see that U is directly proportional to V, whereas V is directly proportional to root H. So we can say that U is directly proportional to the root H. U is directly proportional to V. V is directly proportional to root H. So we can say that U is directly proportional to root over H. Whereas but tangential velocity is given as U is pi d n by 60. So U is directly proportional to D into N. Please be careful, it will be some confusion in terms of more terms. Delta in root over H is directly proportional to the Dn, whereas U is directly proportional to delta H into U is directly proportional to the root over H, whereas root over H is directly proportional to Dn. We can conclude that D is directly proportional to root H by N. The discharge through turbine is given by Q, area into velocity, whereas area is B into D, width into diameter. B is width, area is directly proportional to the D square. Q is directly proportional to D square into root over H. We already known in last term, whereas velocity is directly proportional to root H. So D is directly proportional to root H by N. From this we can substitute D is equal to root over H by N is substituted here. So delta root over H by N whole square into root over H, nothing but H by N square into root over H, nothing but H cap 3 by 2 by N square. So we can conclude that discharge is directly proportional to H power 3 by 2 by N square. From this we get the problems. They given Q1, N1, we need to find Q1, Q2, N1, N2, H1, H2 we need to find out. In case they given H1 and H1, H2, N1, N2, Q1, then we need to find out Q2. Simple questions will be asked in our problem exams. P is directly proportional to Q into H, whereas Q is equal to H power 3 by 2 n square. P is directly proportional to H 5 by 2 by n square, whereas Q is directly proportional H cap 3 by 2 by n square, whereas P is directly proportional to H power 5 by 2 by n square. We in directly proportional, so we taken as K constant, where K is a proportionality constant. If P is equal to 1, H is equal to 1, n is specific speed, ns, substituting value in the above equation. We got it as K is equal to ns square. If you substitute P is equal to 1, H is equal to 1, n is equal to ns, K, we got the value of K value. So if you substitute K value, P is equal to ns square H cap 5 by 2 by n square. You need to keep your book while you listening this video, because there are many terms. If you need write neatly, it will be easy. In 1 or 2 revisions you will remember easily. Whereas ns is equal to root over n square into P by H power 5 by 2. Next, specific significance of specific speed. Whereas specific speed plays an important role for selecting type of the turbine. Specific speed, how much speed we need to generate. Also, performance of the turbine is predicted by knowing the specific speed of the turbine. Performance is based on the specific speed of the turbine. We need to select based on the specific speed of the turbine. The type of the turbine for the different specific speeds are Pelton wheel with single jet. You can see the 10 to 35, 18.5 to 30. You can see these values. Pelton wheel with 2 or more jets, Francis turbine, Kaplan or Francis turbine. Whereas unit quantity defined when turbine is operated at unit head. Unit head means 1 meter. If you take in 1 meter, how much speed it can go, how much speed it can rotate, how much discharge it can give in, how much power it can generate. Same turbine at different head conditions. Unit speed NU, you already know that U is directly proportional D into N. D is taken as a constant. N is directly proportional to delta H, whereas N by delta H, root over H is equal to K constant. If head is equal to 1 meter, N is equal to NU, we got it as NU K value. K is equal to unit, specific unit, whereas N1 by root over H1 is equal to NU, N2 by root over H2. In case of unit discharge, same thing. Unit head, discharge under unit head is equal to directly proportional to D square root H, whereas K value we compare. If H is 1 meter, see, we already said that unit quantities are under the unit head, so we are substituting H is equal to 1, whereas Q is equal to unit head, Q1 by H root over H1 is equal to QU, Q2 by root over H2. They will give 1 value, 2 value, 3 value. We need to find out other value. Unit power is directly proportional to PU is directly proportional to Q into H. We already know known as Q is equal to root over H, so we directly substituted. We got it as P by H power 3 by 2 is equal to K, whereas head is equal to 1 meter, P is equal to PU. We got this. So we got the we get one formula for unit speed and NU N1 by root over H1, whereas we got a one formula for unit discharge, unit power. Same kind we compare the prototype and model, whereas U is directly proportional to the Dn, directly proportional to root H. root h is directly proportional to dn, whereas h is equal to d square n square. H by d square n square model is constant, whereas it's prototype. Prototype is different from model. Model means we actually do, prototype means we do with small dimensions. Whereas we calculate the same thing like discharge coefficient, q directly proportional to d square delta h, ade root over h, where d square d into n, q is directly proportional to d cube n. We compare model and constant, q by d cube n model, q by d cube n prototype. Whereas we power constant, q is, you know that q is d cube n, h is d square n square. So we compare prototype and model. Model p by d power 5 n cube, constant p by d power 5 n cube. Specific speed n root p h power 5 by 4 prototype, n root p h power 5 by 4 model.